2.3 I'll just go over quickly. Hopefully this first one looks familiar. I'm going to find the distance, the vertical distance. This one is 2, 2, 1, 2, 1, 2, distance, 1, 2, 1, 1, 2, 1. Find the sum. I add all of these values up. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4. You got 18? Yeah. Thank you. Then I want to find the average, which means I take the 18 and I divide it by how many numbers I added up, which was 12. 18 divided by 12. It's rounded, right? It's nice, 1.5. I don't have like long decimal. Do you think the line drawn fits the data points? You may say yes or no. You just have to explain your reasoning, why you think it fits. Personally, when I look, I like to count the top. 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9 on the top, 9 on the bottom. Personally, I would say that it's balanced because there's equal distance, vertical distance on both sides. But you could disagree. If you want to, you just have to explain your reasoning. Any questions? All right, this one I did not enter, so I'm going to pull the calculator over. Now, when you have your table all filled out and you want to fill in a new table and you don't want to have to copy over it, you can refresh, click reload, and it resets your data. So it's a clean table. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Negative 4.84. You let me know if I make a mistake when I type it. 2.58. Negative 0.02. One, 14, 14. Were there any mistakes? No? Thank you. Okay. I go to this box. I want the linear regression. This is a line. I do not want the exponential regression. I want linear. My data from my box on the screen, I'm going to copy onto here. so that you know what it looks like in the calculator's window. Oops, negative 0.7. Okay. I'm going to move my calculator now that I have the data written down so I can see what the window looks like on my notes. I will now use this data to build my linear regression. Y equals M. I'm just going to write out the whole decimal. With an X by it. And then the minus B, minus 1.62412. Correlation coefficient. R equals negative 0.730. Questions on those? Okay, turn the page. Oh, these are the nice ones. All right, what is the pattern on the left graph? 1 to 4 to 9 to 16. If I say multiply by 4, that would be wrong because 4 times 4 is not 9. It's not multiplying. If I would do 1 to 4, it'd be plus 3. Plus 3 does not get me to 9. It goes plus 3, then plus 5, then plus 7. That would be identified as neither. That pattern is not linear or exponential. It's a different type of pattern. This table on the notes, these are mean because they are not in the correct order. 7283. I'm going to fix this. Two is at 28. 3 is at 37. 7 is at 73. 8 is at 82. The pattern from 2 to 3 would be 28, 30, adding 9. What's the pattern from 7 to 8? 7 to 8 and 2 to 3 are right by each other. I'm going to see if the patterns match. It's also adding 9. This would be linear. 4 to 12 to 36 to 108, that's multiplying by 3. Exponential. Question B. What is the first graph? What's this graph called? Linear. Linear. It's a line. Linear. What's this one called? Wait, uh-oh. Which one's exponential?
The last one.
The last one's exponential. This one would be neither for now. Math 2 dives into this graph. Looking at the equations, which one do you think is linear? The negative 3x squared minus 4x plus 2, negative 6x plus 11, or 2 parentheses 4 to the power of x minus 1. Which one's linear? It is not the last one. It's the middle one. It is the middle one. Because it is in the form mx plus b. Which one is the exponential one? This one's tricky because both of these have powers.
The last one.
Why would the last one be exponential and not this one?
Because x minus 1 is
X is in the power. Exponential. Which means the negative 3x squared minus 4x plus 2 would be either. This would make the U shape up here. This formula would make a U, like a parabola.